All right, folks, after much ado, we are up and running. Apologies for the delay. Just getting Slack pulled up here. Um, we're still a little bit in testing and making sure streaming quality issues are uh, at least manageable, uh, preferably perfect. We want the streams to be really nice and viewable and intelligible and all that. So do let me know in chat if you're on the in the Slack chat on the Galvanize Slack chat. Let me know how the streaming quality is. Pop an F in chat if it's not doing good. I will monitor that, and that'll help me diagnose issues the more information you give me. I did play around with my settings a bunch on OBS and just my computer and the YouTube streaming, blah blah blah. So hopefully it should be better than it has been. Cool. So last time, I forget what we did last time. I think we talked about dictionary accumulators. If you have a question, again, I'll just put out a general reminder. Study halls, the purpose of study halls is really to give a sort of a public discussion space for your questions. And people can, I can weigh in on them, and other people can weigh in on, we can help each other and see how each other think through problems, and just work together to get through some of these problems. So if you have questions, if you're stuck on a problem in Learn, feel free to pop it in the Slack chat, and I'll get to it when I can. In the meantime, I don't see any questions in right now. So in the meantime, I'm going to just go through the Python materials in Learn. Just check this out here real quick. Okay, cool. So I know we had kind of, when I was going through material before, we had kind of jumped off at lists. I've had a number of people ask me about enumerate. So I want to talk about enumerate and zip. And I know that's in here somewhere. Let me try to find the actual material. I bet it's in manipulating lists. Oh gosh. Perhaps it's an intermediate. Okay, I'm not seeing it right away. If you, I don't want to look for it too much longer. List functions and methods. I bet it's in here, sorry. Count specific items. Min, max, functions and methods. I had thought we had a section on enumerate. Perhaps I'm mistaken. If you happen to find that in Learn, do let me know, and I'll go through it in there. Sorry about that. Okay, we'll just go through it directly. So I've had a number of people ask me about enumerate and what it does. So what it allows you to do, its biggest use case is as the iterator in a for loop. So let's do for element in, I'll just call this EL, for EL in list, and I'll make a list, we'll just print EL for now. List equals, we'll just have a list of numbers. Okay. So this should just print out the elements in the list in order. If I run this. Oh, right. I actually have to execute my code. Cool. All right. 1352877300006. Okay, cool. So this is just a regular for loop, just to show you what's going to happen if we run through the elements of a list. Pretty straightforward. I'm assuming folks know this at this point. If I wanted, let's say, so there's scenarios where I want the index of the collection, where I want the index of every element in the collection as well as the element, right? So if I want to print out, like, you know, let's say this 7, if I want to know what its index is, let's do this. 0, 1, 2, 3, 4, 5, right? So that's going to be index 5. I don't have really a way of recovering the index like every time for any given arbitrary element in the list, right? So what I can do, I can use enumerate here. Enumerate, E-N-U-M-R-A-T-E. And this actually gives me a pair of elements. So element, or what I'm calling EL here, let me actually, I'll call that pair. Oops. P-A-I-R. Okay, so you can see the pair is actually a tuple. We had talked about tuples recently in Premium Prep. I can tell it's a tuple because it's surrounded by parentheses. And then if we look at the elements in this tuple, right, on the left-hand side, if I read the left column of elements, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And on the right-hand side, it's 1, 3, 5, 2, 8, 7, 7, etc. And that's the elements in my list, 1, 3, 5, 2, 8, 7, 7, etc. So I can tell that the elements on the left represent the indices, and the elements on the right represent the elements of the list. So one interesting thing you can do, one really useful thing you can do with tuples, since they're immutable, you can always count on them being the same size without something else intervening and changing its size. So you have like this sort of guarantee in a lot of cases of the size of the tuple, or let's say closer to a guarantee, right? It's not a perfect guarantee, but it's because you know, if it's under an identifier, the identifier could be altered in some way. But presuming it's pointing at the correct tuple, we can do this. We can say IDX, comma, element instead of pair. IDX, L, yeah, go ahead. To the question asker, go ahead and ask your question. Cool. So enumerate is going to give us the index followed by the element in the collection. And we can actually name two different identifiers here. So each of these I'm just calling an identifier. They identify some piece of data. So rather than having one, enumerate allows us to pull apart that tuple right in line with this for loop. So anywhere where you can see it, where something evaluates to a tuple, you can sort of pull it apart into its elements, into its constituent elements, with this A comma B pattern. A comma B is what I mean. In this case, we're going to do IDX because the first element in the tuple that enumerate returns is the index, and then we'll do L because the second element in the tuple that enumerate returns is the element. So this can be useful for that. No worries to the question asker. Feel free to ask your question. I'm going to wrap up this, and I'm going to go to zip. Well, I think I've wrapped up enumerate. We've covered it in other contexts. So I want to talk about zip, and then I will look at your question. So don't, just anybody who's listening to this, don't worry about like interrupting me if I'm in the middle of something. The purpose of study halls is mostly to focus on people's questions. So yeah, that's just fine. I may not get to them immediately as soon as you ask them, but it's definitely not an intrusion if you want to go ahead and put it in there. Cool. So let's look at zip. And so zip is one of my favorite functions. It makes a lot of things really useful. So let's do something like, let's go for client names equals, we'll make a list of client names. We'll say James, Jen, Joanne. And we'll do client ages. And we'll say James is 47, Jen is 38, and Joanne is 25. So I have this data in one list that's associated index-wise with the data in this other list. What I mean by that, it's probably obvious what I mean by that because I just said it as I was typing it up, right? That each of the people listed in client names has their age represented in the same index in the list called client ages, excuse me. So let's say I want to go through, I want to like loop through these together. What I could do is just pick one of the lists, show you the old-fashioned way. For I in range, this is the old-fashioned way, in range len, and we'll just pick one of the lists, client names, and then we can say name equals client names sub I, and ages, or age equals client ages sub I. Okay, so if I print, I'm going to do an F string here. We talked a little bit about F strings. So age is, all right, so let's say name is age years old. Cool. Okay, so this will work. It's a little clunky, and it just kind of takes this like indexing approach, which is powerful, but again, it's just a little clunky. It's not quite an elegant enough solution for Python. We've got this kind of ugly loop here, so we can make this a way prettier. We can use zip, and we can zip. Let's zip client names, comma client ages, and since I did client names first, that's going to give me name, comma age, and then I don't need to do this. And I can fit all that onto one line. I can loop through both of these collections at exactly the same time and have access to their elements just straight away. So let's say I have this. Let's say I wanted the indices along with this. I could say range. I could actually enumerate zip. I could totally do this, but I could do list len, and this would actually give me the index as well. So let's do idx, comma name, comma age. So then I could say client idx. idx's name is this. They are that many years old. Okay. So client zero's name is James. They are 47 years old. Client one's name is Jen. They are 38 years old. Client two's name is Joanne. They are 25 years old. Cool. So this will give me access to the index and the elements from both of these lists at once. Now, just because I said we could, let's enumerate. This will be a little bit different. Okay, so we're going to enumerate. So let's see what happens here. I think we might get an error, actually. Yeah, we do. Okay, so it says not enough values to unpack. So in this case, I think I have to do this. Just surround that in parentheses. Yeah. So this will give me the same thing using enumerate. In this case, I think I actually prefer the range approach. Range length of the list. No, okay, I prefer enumerate. Yeah, I'm changing my mind. Doesn't really matter though, just a personal thing. So if I wanna, I can adjust the index here too, and that's kind of nice. Okay, so client one's name is James, client two's name is Jen, client three's name is Joy, etc., etc. Cool. So zip. This is again one of my favorite, most useful top functions to learn. It's very useful. Cool. All right. Let's move on. If anybody's got any questions. I'm not seeing any questions, so I'm going to move on for now. Cool. I think we can just start going through list basics. Should we just go through list basics? Why not, huh? The overview. So here's the things that the overview is saying we want to know about lists, for list basics at least. Recognize, understand the concept of a collection. Generate a series of numbers using range. Access a value in a list. Determine if something is a member of a list. Slicing a specific portion of a list. Recognizing the nested list. I feel like at least premium prep wise, if you're in premium prep, we've gone through this stuff. I feel like this is pretty well established. If you're not in premium prep and this is new to you, don't hesitate to just let me know. And yeah. Okay. So I am going to kind of presume a little bit of knowledge here and just sort of kind of start blow through this really quick. Maybe spend 5-ish or 10-ish minutes getting through these. So the range function. So I just used range over there. Let's do a brief refresher. Range. Think about when you're learning a new function. Think about what its inputs are and what it returns. Okay, so what is range's input? Well, there are several variations on this. We can feed range a number, let's just say 5, and this is going to give us 5. If we use range in a for loop, it's going to give us 5 trips through the loop. But it's actually the numbers that it's going to give us if we do like 4. Well, let's do it like this. For I in range 5. It's going to be 5 trips through the loop, but we'll print I. And the numbers it's going to give us are 0 through 4. 0, 1, 2, 3, 4 is 5 trips through the loop, but so it's if you're expecting it to start at 1, just be aware of that. Actually, let me do it like this. It's going to work, right? Yeah. Okay, cool. So we can also specify where we want it to start. So if I want it to start at 2, I can pass 2 as the first argument to 5. So this is going to give me 2, 3, and 4. It's going to give me 3 total trips through the loop. Oh, okay, well. There you go. Cool, you get a little space in there, that'll help. Okay, so we have 0 through 4, and then we have 2, 3, and 4. That's our second loop. We can also specify, there's a lot of times where you want to include the like upper limit. So let's say I wanted to do 5 trips through the loop, but I wanted to go through from 1 to 5. 1, 2, 3, 4 is what I'm going to get. So I can actually say 5 plus 1. Obviously 5 plus 1 is 6. I could just say 6 here. Often though, you're doing this with a variable. Like let's just say we have n equals 5, and I'll just change out all the 5s for n, right? And we can pretend like we don't know that n is 5. N could be whatever. So when we're writing this line on line 21, this is just saying we want to start at 1, go through an n total number of times, and we want to include in the value of n, so we'll add 1 to it this way. So this is a common thing to do. So you can see this first loop we get 0 through 4. The second loop we get 2, 3, 4, and the third loop we get 1, 2, 3, 4, 5, right? So that'll be 5 trips through the loop and 5 iterations as well. I think this is a little, having this on one line is nice, but I just realized it may be a little confusing, so I'll put that on the other line like that. Cool. Just give a little space there. Okay. There's also one more thing we can do with the inputs of a for loop. We can specify the step, and let's say let's just do n equals 10. We'll start at 1, go to 10, and actually what we want to do is, let's say we want 1, 3, 5, 7, and 9. We want to print off every other number, so we'll do steps of 2. So we can specify the step with range. I don't know if this is going to give us 1. Yeah, this will give us odds. If I wanted to start on evens, I would have to start it. Specify the start. So it'll include whatever starting place I tell it to include, And then from there, including that starting place, it's going to count every other one, 2, 4, 6, 8, 10, or 1, 3, 5, 7, 9, etc. So it doesn't have to be 2. It could be it could be 7. Because why not? Why not make it 7? Let's make n 100, and we'll get every 7th number. Cool. So, however useful that is, you be the judge of that. There are times when that actually can be useful. So, cool. Well, let's move on. Oh, okay. Excuse me. The range function. Let's do these challenges really quickly. Range. So create a list using range, all the numbers named all the numbers. Okay. Named all the numbers that has. Okay. Create a list using range named all the numbers. All of them. Evidently, this is going to be every number. No. List. Okay. That has the numbers from 500 up to and including 1,000. So that'll be 500, 1,000 plus 1. Of course, I could just do 1,001, but I'm going to do 1,000 plus 1. Cool. Let's try it. All right, you want to create a list of all the numbers between 1 and 1,000. What do? 100 and 1,000. So we're going to do, are they evenly? Oh, that are evenly divisible by 10. That'll be that. Did not complete that. Cool. Okay, so that'll be, I want to start at 100. I want to go up to 1,000, including 1,000. So we'll set the limit at 1,001. We'll go in steps of 10. Range challenge. Okay. So this challenge, you'll create 4 range objects, not list objects. Each assigned to the variable. Let me turn off my heater. A little warm here. You'll create 4 range objects, each assigned to the variable according to the following specifications. So 0 to 50, all the numbers from 0 to 50. Oh, okay. I need my editor. I need my editor skills. Some people have said that they want to see, like, they want to stream on it, like all the shortcuts that I use and stuff, and it's become so second nature to me. I kind of I was trying for a while to say, like, I'm using these shortcut keys, but you need to find a good format to do that in. I'm using Mac right now, and these shortcut keys may differ, and I also customize my shortcuts a lot, so they might not be the same. And I also use Atom, and y'all will be using VS Code, so a lot of them won't be the same. But I do want to go over the shortcuts that I use and how I use them. All the hotkey commands that I use can be found in VS Code. And I do see that somebody put in a question. I will address that as soon as we're done with this. Okay, cool. So let's just pop this in a thing real quick. Da-da-da. Okay, I think I'll just delete this. So 0 to 50. All the numbers from 0 to 50. Okay, so I don't need a range, or I don't need to make these lists. I can just make these range. 0. So these all start at 0. I'm going to do that, and then 50. And then these three just take a, what is it? Yes. Oops. There we go. We'll do that. And we'll say this doesn't need a step because it's all the numbers from 0 to 50. Evens is going to be every second number. Odds is going to be also every second number, but we're going to do this. Well, we need to start at 1. I'm not sure if they want us to include 0 here. I'm just going to assume so for now. We'll see. All of the odd numbers from 0, yeah, because from 0 to 50. Okay, good. And then this one, every third number, starting from 0 to 50. Good. So why don't we print and just see what we get. Oh, right, I didn't make them lists, so we're just going to get these range objects. That's the kind of the funny thing about range is you don't actually get things. You get other things. I'm just going to leave it there. Okay. We're going to get a lot of output, I just realized, so this isn't really that meaningful. I'm just going to say, well, it's probably correct. Because, you know, when in doubt, just ask the tests. Does it work? Maybe not. We'll see. Nope, it doesn't. Cool. Well, I must be a terrible programmer. No, I'm kidding. Oh, right. We want to include 50 doi. So we'll do 50, 51, 51, 51, 51. Okay. Bingo. Accessing list values. Yeah, I think I will do a shortcuts tutorial. I just need to figure out a good way to deliver it for some, because I know a lot of people are using Windows. I haven't had a Windows computer in years. I've actually mostly been a Linux user. I've been like exclusively a Linux user for over a year and a half, and even before that I was mostly a Linux user for a long time before that. The only reason I'm on Mac is my Linux computer had a hardware problem, and it's being fixed, and I can't just go out and buy a new one. I want to, but I'm restraining myself. So, cool. But yeah, I just need to figure out a good way to deliver it in a sensible way that's like people are actually going to be able to digest. That's not just me throwing a ton of things out there. All right. Cool. So let's take this question. Da-da-da. Let's go over here. I'll make a new one. Good. Lower, upper, and capitalize. Okay. So the person asking the question supplied some code. I'm going to use it. So I think, actually maybe, yeah, actually let's look at their code first. Okay, we'll come back to that. This is called string op though, and they're saying, problem 3, okay. Lower, upper, and capital. So these are string functions and methods, which is obvious. Or maybe it's not. Actually, just realized you can't see the whole part of the thing cut off where it says that. Right. Okay. So string up. I love this. Boom. Yeah. This is an example, upper. Okay. So I imagine since we're feeding this, I didn't even read the problem statement. That this is actually a good example. I'm gonna just, we'll start here. Like even before reading the problem statement, if you can see how a function is called, if you can see where a function is called, you can see an example of its inputs. And if you have a reference for what those inputs should produce, presuming the function was kind of written in a sensible way, and will always produce the same output for the same set of inputs, which I'm assuming this function will, because that's how most things are. So if you have a function call with a given set of inputs and you know what the output should be for those inputs, you can kind of discern what it should do based on that. So let's just look at this first. I see, we've got this kind of mixed case example text, and then we have this string just upper, also in sort of a mixed casing, and the expected result is an all capital, all uppercase version of the first argument. So I'm assuming upper tells the function that we want this to be, that we want this, excuse me. I'm assuming that the uppercase version yeah, okay. I'm assuming the second argument is a command that tells us what format we want the first argument returned in. Well, okay. That was a lot of effort to get that out. All right, so I'm just going to look through this. I'm going to kind of try to like understand like where this is coming from, and like where this code is coming from. And the person submitting it is, oh, I don't think they wrote it. I think they're asking on behalf of someone else, but somebody has a question. Is there a difference between Linux and Mac terminal? They are both direct descendants of Unix, and thus they essentially share the same set of commands. I mean, if you know one, you could deal with the other one very easily. They both use a shell language called Bash, or ZSH, which is basically a version of Bash. And yeah, so I would say essentially yes, they're the same. Are they exactly the same? No. There are just little eccentricities and idiosyncrasies that are unique to both Linux in general and Mac in general. What's funny is that in my experience, like since I've been a programmer, I've owned several computers, and for some reason my terminal feels different on each of my machines, and I think it's just because like I install a certain set of software and just set it up differently, and so it's I think at the end of the day, like if you know Bash, you can get familiar with any Bash system, but they're all going to feel a little bit different. I've also used a variety of Linux distributions, and I would say that the terminal difference can vary as much between distributions of Linux as perhaps Mac does from Linux in general. So I would put it in the realm of sort of Unix-like terminals. Okay, that was a long answer. Okay, cool. Yeah. Cool. So let's go through this. So we got our string op. It takes in a string and a command, right? Oh, I didn't actually read I should read the problem statement first to make sure there's nothing I'm missing. So write a function called string op. This function should take 2 arguments. The first one, called string, is a string, shocking, on which an operation will be performed. The second one, called command, can be any variation of the words upper, lower, and capitalized. For instance, upper could be spelled mixed case. So we're looking for any character-wise any command that is the same in its characters, not necessarily the same. Well, the same in its letters, not necessarily the same in its casing of those letters. Fortunately, this is about manipulating string case, so we should be okay. So this function should return a new string that is the result of the command. Blah, blah, blah. Okay, good. Looks like I have the right idea here. I'll just delete this. Good. All right, let's see what this code does. Oh, invalid command. Yeah, so if we don't get a valid command, we should get an invalid command. That looks like this. What this is handling here, that looks good to me. We'll leave that there. So let's just work through the errors of this one. This is an attribution error. String object has no attribute command. Okay. So I see what's happening here. It's kind of an interesting idea. I wonder if there's a way to get that to work. You know, to just like take in the command and like literally use the string as the command. You know, as the substrate for the identifier of the method that you want. But that's a super weird way of putting that. But I see what the intention is here, and it's a cool idea. I don't know how to bust it out like that off the top of my head, unfortunately, but it's a neat idea. Well, let's see though. Let's see what we can do with this. So I see this condition is checking if the lowercase version of command is in the list called commands that has the valid commands. You know, I think what I would do is just do command lower equals and then just check the string directly. Oh, I know I'm supposed to use single quotes, but I'm just gonna make all of these double quotes because I like it. No offense to if you use single quotes or anything. Okay, I'm just gonna check this directly, and then if I realize, okay, command.lower is equal to upper, we can just return string.upper, just like this. And let's just do that for the other two as well. Oops, copied another one. So let's go here and here and here and here. So we'll do upper. Oh, lower. 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 And the next one is capitalize. Capitalize. Okay, good. I got these consecutive ifs. I don't technically need that. So we'll just make these elifs like this. And then if it's not any of those, we can just say else, just return an invalid command. So let's just see what happens. This is an example. Excellent. So I always like to have a few tests in place. So let's do and capitalize. I feel like I spelt that wrong. Well, I think we know what to expect. I'm not going to write the expectation there because it's kind of arduous. Cool. So we get the uppercase version, we get the lowercase version, and we get the version that starts with a capital. So this appears to work to me, and I can think of another way. I think I can think of another way to solve this, and let's try that in a second here. This is a great first solution though. This is like, oh shoot, I don't need this commands list anymore. And get rid of that. I forgot to do that. Okay, we'll do that. Cool. So this is a great first example. We've got condition checking, and you know, like you might look at this and say, oh well, it could be optimized or something, and I don't know. Who cares? Like it works. It's boneheaded, and I mean that in a good way. Like boneheaded code is nice because you can read it. It's really nice to just like deal with code that's just like real straightforward. You know, there's no like high-end philosophy happening. It's just like, okay, it just is what it is. You know, we can just check, okay, if the lowercase version is equal to upper, we know what command we need to run, so we'll just specify that directly here. And that's good to go. And that's not, you know, I hope, you know, the person writing this code, I hope you don't take that as like, oh, you shouldn't have done it that way or anything. It was a cool way you were thinking about it. I would just, you know, I'd just add like, you know, don't be afraid of simple feeling code. Simple feeling code often just works really well. It's kind of robust and nice. It's effective. Okay, I did think of another way. I thought I could do, yeah, this is kind of funny. I could do a dictionary where the keys are the commands. I could say upper. Let's do this. Upper colon string dot upper. Yeah, cool. I think this will work. Boom, boom. Lower. Capitalize. Okay, and then we'll just do sub command dot lower. I think this is going to work. Okay, that's a nice, pretty dictionary. And you know what? We'll just return it. Just like we don't got a care in the world. Just return that right there. Because why not? Because why not? Okay. I'm just doing this just to format it because I'm like evidently kind of OCD about how things are formatted. Cool, so this apparently works as well. Let's see if Learn likes it. I'm just going to comment that out just so I can have that as a note for later. Ah, okay, there we go. Boom. It does not like it. Okay, let's see why it does not like it. Thunderdome, key error, Thunderdome. Ah, okay. So this gives it, I forgot if we get an invalid command. I did not handle this case in it, and we got a key error because I got a command that is not part of this. When you subscript into a dictionary in this manner, just with square brackets, you're prone to getting a key error. This is what you should do by default, right? And then if, here, let's do this. Oops. Thunderdome is not a casing standard for strings, right? So Thunderdome, key error, Thunderdome is not a key in the dictionary. That's what this is saying. There's a way around this, but your first guess with dictionaries should always be with square brackets like this, even though it's going to give you an error if it's not right. The reason for that, the reason you should default to that is because those errors are good. I was just discussing this with a student today. Those errors generally help you write better code, and there's times when you want to write your solution in a way that it's just not going to ask for the wrong thing in the first place. And in this case, I know if it's not, I have this simple sort of thing to do. If it's not in the dictionary, I know what I want to return. So I can actually ask for this key in a different way. I can use a method on the dictionary called .get. And then I'll pass the key that I want. And if it's not in there, it will return the second argument, which is invalid command. Cool. So let's do that. Cool. So this is an example, and then invalid command at the end. Good. So that'll work. Hopefully. That's what I said the last time, though, so we saw what happened then. Great. All right. Cool. So those are two different ways. This first way, if you're looking at this second way and you're like not getting it, don't worry about it. If you get it, then awesome. If not, it's all good. Gangster with the dictionaries. Yeah, it is. Yeah. If gangster coding is a thing, I guess it's canon now that this is what gangster coding is like. Yeah, I like this. It's kind of cool. This solution up here is fine though, and I'm making an effort to say this because like the primary sort of focus of my job, or one really central thing in my job, is to administer the technical interview. And I see a lot of people fail for bad reasons, and I don't like to see that. You know, when I interview somebody that I think this person knows how to code, but there's some other kind of blocker, there's some other kind of like they're having trouble showing me, and I really need to see it. You know, like getting the sense that somebody can code without actually seeing it isn't enough. You know, like I need to see it. You know. And then also seeing somebody that has a lot of knowledge of the Python language but might have like a workflow approach that is just kind of inefficient, ineffective, is also a shame, because I'm like, okay, I think this person basically knows the language. The way they're approaching this is like, you know, they're trying to turn this size of problem into this size of problem, you know. So if code like this comes naturally to you, great. You know, if this makes sense to you, awesome. You know, if you can look at a problem like this, and like bust out a solution like that, you know, as your like first approximation solution, then cool. If this is confusing and that's not what you can do like right off the bat, okay, you know, if you're doing the if else approach, like I'm not going to hold it against you if you produce working code. Like, awesome, you're doing it, you know. There's no shame in, like I like to say, there's no shame in working code, right? If you have a problem and then you solve it with Python, then like, you know, you did it. That's what's important. Not that you do it in the best, like most, big brain, ultra code, super programmer way. Not that this is. I'm sure somebody, could get this down to like, oh, all you got to do is lambda, and then and then it does your taxes for you too, or something. I don't know. But yeah, for now, this is just another example, and it's fine if you don't understand it for now. You will understand code like that someday. If you don't, okay. Gosh, I talk a lot. Cool. I am. Thank you. I'm kind of proud of it. All right. Let's see. Oh yeah, here we the person who wrote the code is saying that this is a brute force way, and yeah, the if. Well, sorry, they're not saying that as a criticism. I'll read the comment. You got the brute force way was trying to use the input command as the command to upper, etc. Yeah, so that is a really cool idea, and I feel like there's a way to do it. It doesn't occur to me off the top of my head, but I have a hunch that that's possible, although I'm not totally sure. It might not be possible. But yeah, the brute force way is always acceptable. Or often. Let's say often acceptable. Cool. Anybody else wants to put in another question? I know somebody was saying they wanted to ask a math question earlier. I didn't see that question. If you're still on, I'm definitely open to that question. If anybody else has a question, I'll be happy to take it. Yeah. Maybe we'll just continue on from here. I'm kind of like sick of lists. Ugh. Tired of lists. Stupid lists. String functions. Let's do some strings. Strings are way cooler than lists. No, I'm just kidding. Oh, string functions. The list function. Great. I go do some strings, and the first thing I get is the list function. Well, we know what a list function does. So check this out. We got x equals print me. We print list x, and we got a few options for what this might be, but we can see that in any case, it's just going to give me a list with every character in its own separate element. And by every character, I mean every character, so including the space and the period. So we just have to look for one. Looks like this one includes the space and the period. This one omits the space but includes the period. This one omits the period but includes the space. And this one omits both the period and the space. So we'll just go with the one that has both of it, because that's the correct answer, and you should always do the correct thing. Remember that. That's a little pearl of wisdom for you. If you just do it right, then you don't need to do it the wrong way, I guess. No, I'm messing around. Okay, complete the function called split sum. This function should take a single parameter called numster. We got another question. Cool. I'll complete this one, and then we'll take the question. Complete the function called split sum. The function should take a single parameter called numster that is a string consisting of numbers. Oh, interesting. This function should split the string apart and then sum the numbers together. Okay. Cool. So we're going to get an input of a string of numbers, and then we're going to get the sum of each of those individual digits is what's going to happen. Right? So if I... Oops. So I'm thinking about this as calling it. So let's make some tests. So we'll do a string of this and a string of this and a string of this. Good. Okay. So 4 plus 5 is 9, plus 8 is 17, 18, 19, plus 9 is 29. So this should be 29. I might have done that wrong. I don't care. If it's close to 29, that's probably good enough. So 1 plus 2 is 3, plus 3 is 6, plus 6 is 12. Well, that was kind of a neat series of numbers. Yeah. And then 8 plus 8 is 16, plus 2 is 18. Good. Okay, so we should get something at least close to 29, 12, and 18. Might be off there a little bit, but I don't care. So we'll do 4. All right, we want to split them apart. I don't think we actually need to use split here. Well, anyways, let's just do 4 num in number stir print num. Num. Let's just start off with that. Make sure we're actually going to get the numbers that we want. Okay, good. 882. That's that last call. 882 looks good. ACC for accumulator. This will start at 0. So I'm going to say ACC plus equals int num, and then I will return ACC, and we'll see if I did addition correctly. 28, 12, and 18. Nope, I didn't. 28. There we go. That's fine. Cool. So I'm going to see if this is going to work. It said to split. Did it say to actually? No, it never said to actually use the split method on the string, but this does kind of split it apart. I must have just conflated that. Okay, cool, that works. I thought of another way, a less brute forcey way, but whatever. Again, I like the brute forcey way. What was it? Now I'm forgetting the other way I thought to do this. Oh, let's just delete this then. So I haven't. Oh, right. I think we can just do return, and then I always get weird with map, but we'll do some list of right, map int, oops, comma, number, stir. I don't know if this is going to work. 28, 12, 18 is what I'm expecting. 28, 12, 18 is what I get. Okay, cool. So I always get, it's weird. It's like I think I know how to use map, and then I'm like, I'm going to use map. And then it's like I just fumble with it sometimes for no reason, and then I give up on it. But I did it right this time. Maybe my map curse is over. So here's a different way. This is a one-liner. Again, same sort of deal, right? Like if the brute forcey way is what occurs to you to do this, great. You know, like your first approximation solution, like the first time you get a problem working, it's a proof of concept. You're just trying to get a working solution. You're trying to get from point A, which is a problem without a solution, and point B, which is a solved problem. That's what's most important. On the TI, that's all I care about. If you can write this code, that's what counts. If you bust this move, I'll be like, nice, nice. I'll probably say it like that too. And this is great. This is great too. Nothing wrong with it. But if you're not writing code like this, I get a lot of people that are like, oh, I'm not writing this kind of code. I can't really do it. And it's like, nah, you can do it. You know, if you can write this code up here, you're doing great. This is just like a different dimension of this. There's a formal, dare I call it a tradition around this idea. In test-driven development, there's a phrase called red-green refactor. So red means you write your test and you run it before you have a working solution, and you ensure that the test can fail. If you wrote your test in a way that it can't fail for whatever reason, then getting a working solution is invalid. So you want to make sure you wrote your test in a way that it's failing, so that your valid result, or that your working result, is valid, right? So I'm using these simple tests, so writing them in a way that they can't fail is kind of hard, right? But I always run them, or often run them ahead of time before I write the solution, and they just print none, and then I know, okay, I'm starting in a good place. So that's red. You get your tests to prove that they will fail, which is the utility of tests. That's why you write tests. Then you get them to pass, and this is what I mean. Get them to pass. You're not trying to write elegant code. You're not trying to write perfect code. It doesn't need to be sleek or nice or perfect. It just needs to work. Green. Red, then green. Green means just make it pass. And then refactor means, okay, now that I've proved that I can solve this problem, I have something which is better than nothing, right? Now I can go back and I can look at this and say, hey, is there a way I could do this better? Is there a way I could clean this up? Is there a, maybe a little touch-up I could do? And maybe it's removing print lines. Maybe it's removing other comments that you were using to help you remind you of things. Or maybe it's adding comments if something is unintuitive and you're like, no, I know it needs to be done this way, but it's not obvious. So to myself or somebody looking at this code later, we want to leave a note and say like, hey, I did things this way and there's a reason. It might not be obvious looking at it, but there's a reason. So it might be just cleaning your code up, or it might be looking at it and be like, oh, I can actually just do this in a line, and this is going to be a little faster, a little better, and that's fine too. Cool. I wonder if I don't even need that list step. This might work. It might not work either, but we'll see. Who cares if it doesn't work? It does work, yay. So I can just sum a map over each of these integers. So real quick thing here, what map does is it takes a function. Int is a function. It's treating int as a function. It's assuming that whatever this first argument is a function. Notice though, I don't invoke anything. I don't invoke the function, and I don't pass in any elements. I don't pass any arguments. I just name the function. So it takes an uninvoked function. The reason is we don't want to pass it what the function returns. We want to pass it the name of the function. We want to pass it the name of the function so that map can invoke the function internally. Then we pass it something like an iterable. So a map is sort of like a for loop, right? It takes a process, which is the body of the for loop. That's this ACC plus equals int num is the body of the for loop here. And it takes an iterable, which here's the iterable in the for loop, and it applies every element of the iterable to the function and returns that, right? So if you look, that's what's happening here, right? We're saying go through this iterable numster in the for loop, and then in the map we're saying go through the iterable numster, and then I'm saying, every time you have a new element in numster, I want you to run this process. In this case, it's just a simple single line, ACC plus equals int of num. With map, I'm just saying apply the function int to every element, and it's essentially kind of saves it in a list. If you try to print map directly, you're not going to get a list, so you need to cast it as a list explicitly to actually make it be a list. But I know, well, if I can get all the elements in a list as an integer, then I can pass that list of integers to sum, and sum will give me the sum of a list of numbers. It doesn't have to be integers, it can be floats too, but And in this case, sum is smart enough to say, oh, well, this isn't a list, but I can iterate over it, and everything inside of it is a number, so I can still do a sum on it. So it's smart enough to know how to do a sum over a map as well. So that's what that solution is about. Okay. I will take that next question. Oh my gosh. Time flies. We'll go a little past 5:30 today, because we got a late start. Okay. Apologies for keeping you waiting to the question asker. By the way, if you're wondering, I just not saying anybody's name on stream just to give people anonymity and such, since this is a public, sort of a public stream. You know, it might feel a little weird because some of you I interact with. Okay, let's do this. Boom. Come on. Chrome, do as I say. All right, so we got parallel lists. The last question on parallel lists is what it looks like. We want to cover. Okay. That's probably gonna. Oh wow! I can't believe those characters actually came through. That's kind of neat. Boom. Implement a function called that, which takes two lists of positive integers and computes the summation. Okay. L1, L2. Okay, so this is saying, oh boy, formal math notation always trips me up, to be honest. This is a dyslexia thing, I think. The way math is written is, I think, specifically designed to bother me. But, well, I'll see what I can do. So the sum over, sorry, k starting at 1 minus, or negative 1 to the k times, double sequence sum. Implement the function which takes two lists of positive integers and computes the summation according to this. Okay, where a sub k and b sub k refer to the kth elements of the two given lists. Okay, this is going to take a lot of banging my way through this. But that's fine. I'm going to show you how to bang your way through a problem, I guess. This is like messily go about this. All right. So let's do 2, 5, 3, 4, and 8, 9. Oops, that's not a comma. That's a square bracket. 9, 9, 3. Okay. Assume that both lists will be the same length and take note of the string index of the summation. Okay, so since I see, do I see k in here? Yes, I do see k in here by itself. I see it as a superscript to -1. So I'm going to do for idx, which is going to be, this is k. I'm going to call it idx. For idx and num in, oh, excuse me, let's do num1. I just demonstrated this, num2. Who knows where I just demonstrated what I'm about to do here? I'm kind of giving it away, but I think there's kind of a delay, but I'll just give you a second to think about this, and you can put it in chat too. All right, so we can do enumerate zip nums a nums b, and what do we want to do? So we start k at 1, it looks like. There we go. So what did we want? We wanted to do a summation, so let's do ACC equals, we'll start it at 0, and we'll say ACC plus equals, and we'll probably let's just return ACC RATURN ACC. Oh, right. I was like, why is it not highlighting right? Right, there we go. So ACC plus equals what? What? So this is going to be -1 to the k to the IDX, more parentheses. You might be like, oh, I don't want to add all those parentheses. Do it. No, sorry, that was, but seriously, do it. Just do it. And then we'll say, I'm calling this num1. Let's just call this A and B. So we'll say A plus B over, again, more parentheses. And then I've got this whole thing over here that's going to be another term all by itself, so we'll do that. And then we'll say 1 plus A times B. Okay, so I think you just let that go its normal route, but I'm going to just do more parentheses anyways. We'll do a set there, and then 1 plus multiplication goes first. So 1 plus whatever that is. Woo! All right. Let me get a little space in here. Oh, no. So that's that. And this is that. And that's for this right here. Okay. That's nice and readable. I mean it, by the way. Okay, cool. I don't know if that's actually what I expect here, but we'll see. I'm fully expecting this to fail, but that's fine. I mean, I'm going to get an error message, and then it'll tell me what to do. Oh, I got it right. Okay, well, there we go. I guess no error message. Alas. Cool. So let's look at this. This line feels super dense to me. So let's just break this out a little bit more. Let's go. And let's pretend like we're not going to use any parentheses. It's probably going to make it way more readable, honestly. And it's going to backfire on me. I'm going to be like, use them parentheses. And you're going to be like, oh, that's way better. You do need the parentheses around the -1. Otherwise, that'll be -1 to the IDX, which is different. So we do need the parentheses around there because that's absolutely essential for this to be regarded as -1 in this case. So I do find this harder to read. I know it might seem easier. It's a little simpler, but honestly, this might just be because I'm dyslexic. It's like I have a really hard time, you know, I say this might be because I'm dyslexic, and I say that as like a, here's a caveat, and your mileage may vary. To be honest, though, I see people struggle with this. Like, looking at code and like knowing its order of operations, I suspect in this order it is going to work. 17.39973 is what I'm expecting. No, this actually gives us a different result. 133. It actually gives us a totally different result. So I would need to like move stuff around and change the order to control the order of operations. And there might even be points where I need parentheses anyways. But I have a hard time with this, and I've seen others who evidently aren't dyslexic struggle with this as well. Laying out a problem left to right using the inherent order of operations to control the order in which the problem is executed. So let's do PEMDAS, PEMDAS, parentheses, which we're not doing. Exponents, okay. So we know exponents are going to be done first. So that means -1 to the IDX is going to be resolved before anything else. So -1 to the IDX. M is multiplication, so it'll be the product of this times whatever's on this. So I think that's going to be this times A, right? It's going to be that times A, and then it's going to be A times B. Those are going to evaluate next. And then now we have the product of this, which is already wrong, plus B over, so it turns it into, so let's parenthesize it in the way that the order of operations is going to assume, and maybe that'll make it clearer, right? So that's going to be one thing. This is going to be another thing. And then that PEMD. So it'll be B over this, actually. B over 1 plus A. So this is all out of whack, right? Like this is nowhere near the same order of operations that we asked for in this problem. This is why I'm a big fan of just like don't write it out and then go back through, because what you're likely to do is follow the order of operations like this. As you're writing it out, really think about it and make sure you're committing to an order of operations that's actually going to solve the problem you intend to solve, right? So again, that is not the same as either of these. And the second line here is the same as the first, just without the spaces in it. But they're exactly the same. For IDX AB, yeah, okay. So this has to do with unboxing a tuple. Enumerate returns a two-piece tuple. Zip returns a tuple of whatever length for however many arguments you pass to zip, right? I'm passing 2 arguments to zip. So zip's going to return a 2-piece tuple. Okay. So how does that bear on whatever the heck is going on in the identifier here? If let's actually rewrite, I'll do this. Or actually, yeah, we'll save that original line. So let's see, if I don't do any of this thing, let's see what thing is, right? So for thing in enumerate zip, blah, 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 Let's print thing. So remember, this generator gives us back some piece of information every trip through the loop, and it's a different piece of information. In this case, it's a collection of pieces of information with multiple pieces, right? So let's just print out what the thing is. So we have parentheses 1, parentheses 2, 8, end parentheses, end parentheses. Then we have 2, 5, 9, end, and then parentheses 3, parentheses 3, 9, end parentheses, then parentheses 4. So, I mean, you can see we have on the left-hand side, if you look at that 1, 2, 3, 4, that's our index from enumerate, right? So that would be our IDX. IDX, okay. So I can pull out that IDX. Now let's do IDX. Good. So I can unbox that level easily, right? The problem is that we have a tuple inside of a tuple. So this unpacks one tuple, but when I have a nested tuple, things get a little weird, and I can't just say, you know, thing 2, right? I can't do thing 1 and thing 2, because imagine that my data was structured like this. We'll do the index. We'll just start at 0, even though we're starting at 1 here. We'll do the index, and then we'll say banana, comma, peanut butter. I haven't eaten today. Wonder what that's about. Banana and peanut butter. And then, I don't know, let's just throw a Boolean value. True. True. I didn't do that on purpose. Okay. This example is too silly. It's way too silly. So let's do 3 and 5. I don't know. Let's just do that instead. And then let's say for whatever reason I have data that is structured like this, right? The elements in this outermost tuple are this, and this, right? So having code that takes apart the inner tuple without specifying that it's the inner tuple is, you know, that would be problematic, because you wouldn't be able to pull apart something like this in your for loop. I don't know that you'd really have data that's modeled like this, but it's possible, right? So if you have a list of tuples and you actually want to represent each tuple as a tuple in your for loop, this kind of code has to be valid. But if you want to pull apart that inner tuple, you have to specify, okay, I'm nesting down, I'm going into that inner tuple with the parentheses, and then it knows to actually pull apart that innermost tuple. AB corresponds to nums A and nums B. Yes. AB corresponds to nums A. Yes, so A is going to correspond to each element in nums A, and B is going to correspond to each element in nums B. It's a much quicker answer. Yes. Cool. Yeah, if I wanted to, yeah, so it would be IDX parentheses thing 1 thing 2 in parentheses comma num is correct. Yes. If I was modeling data in this fashion on line 20, where I have an integer and then a 2-part tuple and then another integer, and I wanted to pull them apart in a for loop, it would be like that. Yeah. if I had a list of these, let's just try that out. For IDX, comma, thing, comma, or let's do this. For IDX tup, this is one way, and num, right, in this. And this would be if I wanted tup to actually be represented as a tup. If I didn't want it to be represented as a tup and I wanted to pull it apart, I would do thing A, thing B. And that would pull apart that tuple correctly. So both of these are valid. I'm going to throw this into Slack just for reference so that it can exist somewhere. You can copy it for your notes if you want. There's some terrible code. Enjoy. Boom, boom. I think we can just clear that out. There we go. Good. All right. So I'm thinking this is a good place to wrap up. I'm usually ending at about 5:30. There are cases where I'm willing to go longer till about 6. But this is a good place to wrap up. I had a long morning, so I'm looking forward to grabbing something to eat and enjoying the rest of my evening. I will probably be on and off of Slack for the evening if you have any questions. And I know some of you have Slacked me earlier in the day. I am going to work on getting back to you as soon as possible. I got a little bit of a backlog to go through. Let me know if the streaming quality was good before you leave. If you're in Slack, give me a thumbs up regarding the streaming quality. If it wasn't great or if it was shaky for you, give me a thumbs down. The streaming quality issues, I think I've got them, but I think I've got it under control, but I'm just kind of worried about that. I definitely want these to be good. Cool. Yep, so I'll be streaming again on Monday if all goes well. And I'll be teaching Premium Prep tomorrow. So if you're in that, then I'll see you then. And like I said, feel free to hit me up on Slack. I might get back to you this evening. I might have to wait till tomorrow. And I'm probably just going to not be around on Sunday, but I'll be around on Monday. So yeah, that's it. Have a great rest of your evening. Bye-bye, y'all. You're welcome.